Hi everyone, welcome. My name is Felipe and welcome to our fireside chat with Ajeya Cotra on timelines for transformative AI and language model alignments. Ajeya Cotra is a Senior Research Analyst at Open Philanthropy. She recently published a report estimating when transformative AI may be developed using biological anchors, which is an input into how much capital should be allocated to the potential risks from advanced AI focus area relative to other areas. She also collaborated extensively in writing the Alignment Research Center's recent report, Eliciting Latent Knowledge, and published a piece advocating for aligning narrowly superhuman models. So let's get started. Welcome, Ajeya.
Thank you, Felipe. Great to be here.
So to start us off, have your views changed at all since writing the post on aligning narrowly superhuman models?
Yeah, I think that since writing that post, I've been thinking more deeply about various different aspects of alignment. And I would say I kind of have more specific views on like which kinds of empirical alignment projects are good and why. And I think I would broadly still stand by the aligning narrowly superhuman models point of kind of look for places where AI systems are better than humans already at certain things and try to find ways to get them to be as helpful as possible. But I think there's I've thought a bit more about things like interpretability or just kind of particular projects that don't look like that might still be helpful and maybe kind of gradations in how helpful different versions of aligning narrowly superhuman models might be.
And when you say useful, you mean like in terms of like usefulness for alignment research or usefulness for users?
Usefulness for kind of preventing super intelligence style scenarios in which AI systems that are trying really hard to maximize something that humans don't want, ending up kind of getting all of the power in society.
And maybe on that point, how do you see research on this narrow topic connecting with the broader or like core alignment problem?
Research on the aligning narrowly superhuman models. So basically the concept here is that in the future, we're going to have AI systems that are smarter than humans, better than humans in a wide variety of domains. And that brings particular challenges in controlling them and making sure that they're not going to do something that we don't want to do. Because once they're that powerful, if they're trying really hard to accomplish something that is not quite what we wanted, like trying to get the literal reward number in their computer to be a really high number, that could lead to really destructive kind of power-seeking actions, such as trying to gain physical control of their computer to, set the value to a high reward, for example. So like a chief challenge of trying to do research now to prevent this future outcome is that systems now aren't powerful enough to take really scary open-ended actions in the course of achieving their goals. So, StarCraft playing AI isn't smart enough now to try to bribe its opponent into throwing the game in order to get it to win. It's kind of got this limited action set, which involves like doing things in the world of StarCraft. And so even though it's trying really hard to win at StarCraft, that doesn't lead to kind of scary open-ended power-seeking or deceptive actions. And so one potential patch or way to try to study something useful anyway today would be to look for certain specific domains where AI systems do know something that humans don't. So for example, an AI system might know more physics than a certain group of humans or something. And trying to get those AI systems to be helpful to the humans, even if the humans were kind of naively looking at their outputs, the humans would be kind of rewarding them for the wrong thing. So a human that has misconceptions about like tough physics problems, it's sort of not obvious how to get those humans to give useful feedback to these models without incentivizing the models to just deceive the humans. And that is potentially usefully analogous to this problem where in the future, models might be kind of open-endedly trying to optimize for reward or whatever else they want. And then that might kind of lead them to try and seek physical control or seek power over humans or try to remove human control over their training environment or their rewards.
Thanks. And one question from the chat. Do you know of anyone addressing or working on the issue of perhaps language models only knowing how words are used and not having sort of symbolic knowledge about what these words actually mean?
There are definitely people who think about that question. My best guess is that in the future, as language models get larger and larger and are trained on higher and higher quality data sets, we'll see more and more coherence of the kind that this question is gesturing at emerging. So, language models of the past were very much just kind of repeating shallow statistical patterns in words. Language models today are capable of kind of sometimes doing things that look like reasoning. So, most recently, language models did pretty well on kind of grade school math word problems. And I think that trend will continue, and language models a few years from now will be a lot better at kind of coherence and logical or symbolic reasoning without a particular algorithmic intervention that's like specifically targeting that. Although like just a lot of interventions or a lot of innovations will just kind of make it easier and better to train these models to be useful.
Now pivoting to your report on using biological anchors to estimate when transformative AI may be developed. What do you make of the recent critique by Eliezer Yudkowsky on this report?
Yeah, I mostly agree with Holden's response to that critique. Eliezer is sort of making the assumption that the report assumes that the only way to get transformative AI is by training these large models. But the sort of real thing that I think is needed to get that analysis off the ground is to expect that that's a way to train these models. So thinking about that question can still provide a rough upper bound. And kind of the reason that I treat this kind of rough upper bound as more like a median is that I look at one input, which is compute. And I didn't specifically think about when the data or environments might be ready. And I generally feel like sort of extraordinary and extreme claims face a certain burden of proof. So I think Eliezer's perspective here is something like, that's just like extremely uninformative, and I disagree with that. Though I do agree with him that like, it isn't like the way the report is structured, it's not automatically going to knock down anyone's particular inside view sense of how you might build AGI that might include elements other than deep learning. I'm generally somewhat skeptical of like inside views on how we might build AGI that result in the belief that AGI is really soon. But that's kind of a separate thing from biological anchors. And each of those arguments would kind of need to be examined in turn. And I think Eliezer has something in mind that for info hazard reasons, he's not sharing. But I think the report is kind of more responsive to someone who is either like, I have no idea what to think about this question, or believes that AGI is definitely hundreds of years away and is like not something that could plausibly happen soon. So I think the report is kind of a more powerful response to that kind of perspective.
And then a similar question to the views changing. Have you been surprised by any recent developments? Have your timelines changed significantly since writing that report?
Not significantly. I think a mildly surprising recent development was the DeepMind language models Gopher and Retro, which were published a few months ago, but actually had been apparently developed more than a year ago. So I was sort of wondering why we didn't have kind of bigger and better language models already. And it was kind of interesting to learn that this group had kind of had them and been sort of sitting on them for a while. But overall, my reasoning is like pretty similar. It's kind of acquired a lot of texture and some specific beliefs have changed, but no dramatic shifts since then.
And in the model, one of the inputs is sort of algorithmic progress. And from the chat, we have a question: how linear is algorithmic progress? What probability would you put on a discontinuous jump in the future pre-AGI?
Yeah, so I think the kind of principled thing that I would have tried to do if I had more time on that report would be to, instead of projecting algorithmic progress as one point estimate that's changing over time, having a distribution that's changing over time, rather than saying, the amount of compute required to train transformative AI halves every 2 or 3 years. It would be saying there's a X% probability that it reduces by 10%, and there's a Y% probability that it reduces by 10X, and so on. And just prima facie, I would expect that what that looks like is that there's kind of a distribution of innovations. There are a bunch of people trying a bunch of different things, writing papers in a given year. And the distribution would probably look like a lot of papers help a little bit, and some papers help a lot, and some papers help so much that they only come along once every 10 years or once every 20 years. The more people are working in the field already trying to claim the low-hanging fruit, the less likely it is that we're going to see a giant discontinuous jump. So that's kind of my general background picture. So I definitely think that a better version of the model would include that uncertainty. And my basic answer to what's the probability of a big jump is it really depends on how big that jump is. And I think my probability over time will be going down because more people will be entering the field and will be trying harder. So there's more of an opportunity for a big surprise next year than 10 years from now when the field is 10 times as big.
Makes sense. And another question from the chat. How much do you think compute is really the factor that will be the sort of determining factor in when we get to automate research and development and having superhuman models? And how much uncertainty you have over that versus it being sort of data or environments or algorithms? And how do you build that into your model?
Yeah, I think compute is pretty likely to play a large role. Historically speaking, progress in the field has tracked pretty well with the amount of compute in the field. Compute kind of helps in 2 different ways. One is that in a direct way, you're able to train larger models, but another is that it makes experimentation a lot cheaper. So you can try more things if running a B-sized model is just a trivial thing versus if it's like a very tough thing to do. So I expect compute to be a pretty big deal. I also expect data to be a big deal, but I think we are, as a civilization, we haven't tried nearly as hard yet creating high quality data sets for these models. We've mostly just been kind of passive. We've been scraping from the internet. Very occasionally, we're just dipping into using human feedback. I think there's a lot more we could do in that direction in terms of paying humans to produce high quality data and high quality simulations to train these models on. So I expect that to be less of a bottleneck because I think there's much more headroom and much more low hanging fruit. Whereas computer hardware is something that as a civilization, we've put in a huge amount of effort into for many decades, and is kind of one of the largest scale, most complicated industrial projects in our entire society to just get it a little bit better. And so I expect that to be more of a bottleneck just because we've kind of wrung out more of the easy wins there, and we've done that a lot less for data and environments. Though I definitely think it'll still be a lift, and it could easily be the case, especially if the compute requirements are pretty low, it could easily be the case that we're bottlenecked for multiple years on creating the right data sets and the right environments.
And now pivoting more to the alignment side of things, what are some things you might observe in the short term which would reduce your uncertainty about the broader problem of alignments?
I think that's a really tough question. There's kind of two categories here. The easiest changes I could see would be just to see AI labs and people in industry taking the problem seriously and seeming to kind of understand the same version of the problem that I understand it to be. So a lot of people working on ML safety right now are mostly working on making existing systems more robust, more reliable, less likely to say offensive things, easier to use, all of which are good, but don't particularly track strongly with this this kind of problem that will emerge, or that I think is likely to emerge when we have kind of powerful, large, open-ended systems. And specifically this thing where no matter what they want, it might be pretty helpful for them to take control from humans once that becomes easy enough to do. So not a lot of people are particularly worried about this problem. And I think that in itself is a source of a lot of the danger in my mind. If kind of there was a societal consensus that, well, the default easiest way of making powerful AI runs like an unacceptably high risk of this outcome, so obviously we need to figure out how to do something else, then my personal estimate of risk would drop a lot, because that's like the first and maybe most important step to solving it. So it might not be particularly difficult to solve this problem, but it will require, I think, at least some mindfulness, coordination, and like directed effort toward it that we don't particularly have right now. On the technical side, I think it's like much less clear and much dicier what kinds of empirical evidence would make me feel better. I think I'm more likely to update based on kind of theoretical arguments at this point than empirical evidence. So, an obvious thing would be if the Alignment Research Center, which is kind of trying to solve alignment on paper, says they found a solution to alignment on paper, or something that solves an important sub-problem of alignment, then that would definitely make me feel better.
Could you say a bit more about the sort of like experts and leaders in tech companies not engaging with the same sort of problem you are? Can you say a bit more about why you think that's the case? Has it sort of been not engaging enough with the arguments, not finding them convincing, or sort of dismissing it out of hand?
I think it's a complicated situation. I think the worry that I kind of take most seriously in this space is pretty sci-fi. It's quite similar to like the Terminator or AI takeover scenarios. So people generally are skeptical that something so extreme and weird is really where we're headed. And I think that's like kind of the starting point for a lot of people. And then from there, people have tried to engage with them, made certain arguments, and they've generally been kind of unpersuaded in my experience. And in my experience also don't kind of seem to have as detailed an understanding of the case for this as I would like. So, one of the things I'm hoping to work on over the next few months is having more conversations, like trying to articulate what I think is the simplest and strongest version of the case that, this whole Terminator thing might actually be real and might actually happen.
And then a question from the chat. So as background, there's been people that think you might get closer to AGI or transformative AI than we think by just scaling up language models. And so in that vein, how concerned are you about deceptive alignments or misalignments, MESA optimizers in language models specifically, as opposed to transformative AI in other systems of AI as a whole?
Yeah, I think that for sufficiently powerful language models, even if they're just doing prediction, it's pretty plausible that being a consequentialist and like kind of thinking explicitly about what thoughts you should think and what avenues you should explore, what hypotheses you should explore in order to get the best prediction will turn out to be useful. So, when you're a very, very dumb predictor, then picking up on like really crude statistical patterns might be the lowest hanging fruit. And when you're pretty good, like GPT-3, then picking up on like kind of grammatical rules and things like that might be the lowest hanging fruit. And maybe when you're very, very good, and you've done all of those things, then being kind of internally consequentialist about like exactly what avenues you explore and don't explore might be the lowest hanging fruit in terms of becoming a better predictor. So, even pure language predictors might well become internally consequentialist, and that might mean they have goals that aren't quite what we would want, and pursuing those goals really hard might lead to sort of power seeking or AI takeover scenario. With that said, I think I'm more worried about language models that have been further fine-tuned with reinforcement learning than language models that are pure predictors, just because I think that it's pretty unlikely that we won't do reinforcement learning to some degree. And reinforcement learning kind of is a much harder nudge, I would guess, toward being a consequentialist that's trying to pursue some goals than pure prediction, even though pure prediction could do it as well.
I know there's another chat question about the broader awareness topic we were just talking about. How concerned are you about the potential trade-off between broad awareness being useful, but potentially concerning if it causes, for example, governments in a way that's concerning to be more involved, or malicious actors that may have otherwise been very focused on AI?
Yeah, I think it's definitely concerning and a tough line to walk, and concerns about this sort of thing are part of why we didn't try and kind of market the timelines report very much. I think it's probably possible. I think there's probably something you could say that would be very positive along the lines of, the default way that we can maybe make powerful AI would be really scary, and here's why. With more of the emphasis on, it would be really scary, and less of the emphasis on, and we could do it for this amount of money, like this soon. So here's like a general template, and once we have enough resources, who knows what those resources might be. We could use something like this to train a powerful AI, and that thing seems really scary. I think is a good message that I think like kind of has a good cost-benefit analysis if you've done it thoughtfully. I also think do this type of research to make it less likely we have a robot apocalypse is a good message that I think has more benefits than costs. And really the dicier message, which is it's tough because I think you do need to say some of this to get people interested. The dicier message is like, no, this really could happen soon. It really wouldn't necessarily be that much money, and kind of getting into the details of that. So our kind of approach has been downplay that, have the analysis there to point people to, but don't draw a ton of attention to it, and be much louder about the potential worries, and most loud about potential solutions.
And now jumping back a bit, you mentioned how future models may be acquire sort of like internal consequentialists. Can you say a bit more about that, and how can we be sure, for example, that GPT-3 does not have this property?
I think it's going to be very tough to tell because it's kind of a property of what's going on inside the model's brain, and we don't have good brain reading for models. So we have people who are trying to do interpretability and mechanistic transparency stuff, like Chris Ola's team at Anthropic, but that whole science hasn't gotten very far. And so I think that it would be pretty tough to devise tests of it for existing models. What I kind of mean in smarter models is kind of something that you might be able to access just introspectively. Humans often make plans, make goals, and also make plans about what they should think about next. What aspects of a problem they're facing like deserve more cognitive attention. And so that is the kind of move that I think might be really valuable for just generically all sorts of future models, even if they're just predicting things. It might make sense to be consequentialist about their thoughts in this way.
And you mentioned before about being one thing that might change your mind is sort of on paper results about alignments. How optimistic are you that progress of this sort is possible if, say, you knew that transformative AI was like more than 40 years out or something like this? Could we still make progress even though we're not anywhere close to these sorts of capabilities?
I definitely think the case becomes weaker. I still think there's a good enough chance that even if transformative AI is 40 years away, the basic principles will still involve, having some sort of scoring function and some sort of search function that like finds a model that finds a program that does well under scoring function. And I think even starting from that very basic assumption, which doesn't necessarily imagine neural networks or gradient descent. You could kind of replace neural networks with something else and replace gradient descent with something else. I think there's still interesting theoretical work to be done. So I would still be interested in funding that sort of thing, but it would definitely seem less urgent to me.
And then jumping back again a bit to broader awareness, how much of these ideas do you need to be taken in by the people making decisions? Is it okay and maybe this could be the last question because we're running out of time. Does it need to be the leaders who are aware of these ideas, or is it sufficient if there's a few people on the team who are sort of concerned about this and can bring up some problems?
I mean, I definitely think that kind of the more people understand these issues deeply, the better, across AI labs, governments, and so on. And, deeply understand not just that this powerful technology might be possible, but also that it might be very, very risky and maybe we shouldn't build it.
All right. Well, thank you so much. It looks like that's all the time we have. Thank you so much, Ajeya, for a wonderful session and for your time with us today. As always, we invite everyone attending to use Swapcard to find fellow conference attendees who share your interests and set up meetings. If you need any assistance, please visit our Siri help desk on Swapcard. Thank you, everyone, for coming.
Thank you.